immensely in other math classes, okay, or outside of this math class? And the answer to that is that it depends. It depends on what route you take. If you go to calculus, you're going to use this. And I don't know, it depends on who you have, what teacher you have. It's going to be a certain degree of how you use this, okay? There's been years where in calculus, I kind of inundate sections with this type of stuff to just get a little bit better at it in those areas. But there's been other classes where I avoid them. Okay, I've observed teachers that completely neglect the trig aspect of calc, and I've seen ones that's all they do. Okay, so it just depends. What you will undoubtedly use though is the byproduct that you get from these questions, and what's going to happen is that you're going to refine your algebra skills immensely with these types of questions. Okay. But I want you to understand that when we're working with these, you've got a lot of different options. If you want to use like a substitution technique, like U substitution, and it makes sense to you, go ahead and use it, okay? But we're going to get better at like LCDs, rational fractions, or rational equations, and how to simplify those things. But it's going to at first kind of seem somewhat abstract simply because there's words inside our equations, like sine, cosine, and tangent, okay? If you feel comfortable taking those words out and replace them with like U and V and stuff like that and doing the work with those letters, like using like literal equations and solving literal equations like we had in Algebra 1, that's a route, and I'll kind of explain that as we go. The other thing is that, in a class, if we're going to try to talk about these, we might not, 45 minutes isn't an immense amount of time to get a lot of these done and kind of discussed in I think, an effective fashion. I have a lot of videos online that you guys can take a look at and use to assist you. The more of these you see, the better you're going to get at them. The more you do, the better you're going to get at them. Okay. If you have questions, never hesitate to ask. I'm going to try to show you tools that can help you decide whether, if you can't remember like an algebraic rule, like, can I add these two fractions the way they are? Can I maybe take the square root of this difference, this perfect square difference or whatever, difference per squares? Maybe use your calculator and substitute values and see if things are okay, if you're allowed to do that kind of stuff, okay? So I try to, as we work through them, kind of jump back and forth between a calculator to check things. Yeah. So the first one here, probably the simplest you're going to see, it says express sine of theta in terms of cosine theta, okay? I think I talked about at the end yesterday. We can kind of draw comparisons to maybe what we've done in the past. If I have like 3x plus y equals 12, okay, if I ask you to graph that, you guys would solve that for what? Y. You'd go y equals 12 minus 3x, right? Okay. Well, you just expressed y in terms of x. Does that make sense? Okay, when they say express something, that means isolate that thing. And then it says in terms of, that means then if there's a variable component that shows up, that is the only variable component that shows up. Okay? The way this one, if we had to write a phrase about that one that says express 12 in terms of x and y. Does that make sense? Okay? So we're looking to take and solve for sine, and on the right-hand side, when we're done, we're going to have some expression. If there's a trig ratio that shows up, the only one that can show up is cosine. Now, it might show up twice and three times and powers and that kind of stuff, but it is the only trig ratio that shows up. Does that make sense? Okay. So, like I told the last class, we have to be able to decide. We have to be able to decide which of these identities do we start with. Okay. We're always going to start with an identity to do this. Okay. So we want to start with one that incorporates both these somehow. Now, it might be explicit, the one we choose. It might be very obvious which one includes sine and cosine. But when we do this one over here, it's not going to be as obvious, okay? It's kind of hidden. But this one, which one of these identities up here incorporates sine and cosine?
Tangent.
Okay, so let's do that. Let's say don't write this. No, I want to, because we did the same thing in the last class. So tangent theta is sine over cosine, right? Okay, so that is one that incorporates these two things, right? Okay, now what happens is that it also incorporates tangent, okay? But if I wanted to solve for sine, I want to get this thing by itself, okay? What can I multiply both sides by to get sine of theta by itself? Cosine, okay? So I multiply the right by cosine, those are going to cancel, right? Multiply the left by cosine, those are going to give me, cosine theta times tangent theta is equal to sine of theta, right? So right now, just kind of look at what this is doing. We have expressed sine of theta in terms of what? Cosine and tangent, okay? But now we also know, so this is what happens with tangent. We know that tangent is also sine over cosine, isn't it? So maybe I do that. Now what's going to happen if I write it that way? The cosines cancel out, right? So I get sine of theta equals sine of theta. Now we know that's true, but now I've solved or expressed sine of theta in terms of what? Sine of theta, okay? So that might be a little bit of an issue. Now, we could keep going, because there is a substitution that we can make here that probably isn't all that obvious, and it's really the substitution that we would I don't want to say it that way. It's the identity. If we were to choose the correct identity, it's the exact work that we would have gotten if we chose the correct identity. So maybe we'll come back to that statement here in a minute. So basically, what that tells me is that wasn't the best choice. Okay. So I try something else. What other ones up there that have sine and cosine in them? That one right there, right? Okay. So I'm going to start with that one. Sine squared theta plus cosine squared theta is equal to 1. So remember, when it says express sine of theta, that means that that's what we're trying to solve for. Trying to get that thing by itself. So algebraically, how do I get that thing by itself? Subtract. So I'm going to have sine squared theta is equal to 1 minus cosine squared theta, right? Okay. Now, sine squared theta, I don't want sine squared theta, I wanted just sine of the first, right? So how do I do that? Square root. So I have sine of theta, square root of the left-hand side, I have square root of the right-hand side, right? So be that, right? Now, when you take the square root, you introduce the square root. You bring it into the problem. You now have a plus or minus, right? Okay. If they start you off with that in the problem, then they're telling you what the sign that they want it to be. Yes, because we don't have the additional information about where theta should be, whether it's in the first quadrant, second quadrant, third quadrant, or fourth quadrant. So we're going to do a little exercise here in a moment to kind of talk about that. But think about this. If I would have gone this first route, again, I got sine theta equals sine theta, but then I come up here and I solve this thing for sine theta, could I now replace this right-hand side right here on this right-hand side?
Yeah.
Okay. which again, that's what I was trying to say, is that this left-hand side stuff, isn't useful because this work gets me straight to the answer, and then I had to do that work before I could maybe use this. So this is not needed. Okay, so here's my question. If I take, so as we're doing these, I think it's a good idea to have Desmos out, okay, or GeoGebra, but I'm thinking you guys are probably going to prefer Desmos a little bit. My hopes are that as I demonstrate some of this stuff with Desmos, that you guys are kind of picking up on it. And what I mean by that is, if I want to make sure that the things that I've done are okay. So, for instance, we started with sine squared of theta plus cosine squared of theta, and that was supposed to be 1, right? I want to see then, well, do I get the same thing then when I go to this next line? Are these two things equivalent? Does that kind of make sense? Okay. So if I say, let's say sine squared theta is 30, cosine squared is 30, okay? Now I want to ask the question, well, if I then try to isolate this sine squared of 30, which all by itself, sine squared of 30 is that number right there, right? Yeah. Does that end up being the same thing as 1 minus cosine squared of 30? So that tells me that this first step, and this is something we should have known from like 6th grade, that when I move this thing over, that's a legal algebraic operation, and what I'm left with then should be true. Okay, it should be providing the same information the statement before it said. Okay, but now if I take a square root, so now if I take let's do it this way. It's raise e to the half power, the same thing as square root. Yeah. So if I do that, okay, I get 0.5. So that means let's come over here and take the square root of this. Does it give me the same 0.5? Yeah, so I know that the algebra that I've done from this line here to that one there was valid. Okay, now those are things that we already knew regardless, but I think maybe it'll make more sense when we do the next example of that. Now, here's my question. It doesn't tell us where theta is. So I want to kind of walk you through what you do when they tell you where theta is. Because I think in your homework, what question you on there, Blaze? 30? 29. Does it say theta in a certain quadrant? In quadrant 4, okay? There's an added step when we look at that, okay, when we have that information. And here's the idea. And it's all predicated off of the idea that all students take calculus, okay? If theta stops in the first quadrant, so let's say that's theta right there, okay? This side would be what kind of number, positive or negative? Yeah, sine in the first quadrant is positive, right? Yep. Okay. So over here, when I look at the right-hand side, I need to make sure that the work that I do on the right-hand side is going to generate what kind of number? Positive. Okay. So here's the thing. When we evaluate cosine or sine, okay, if you go through and look at any number that you plug in for theta, for the sine or cosine, your numbers are going to be between -1 and +1. Okay? And we'll talk more detail about that in Chapter 6. But the sine and cosine functions as curves look like that. Okay? So, like, that value right there is 90 degrees. Your y value would be 1. Okay? So the sine of 90 is 1. The sine of pi is 0. The sine of 3 pi or 2 or 270 is -1. Okay? But as I go through here, my y values, even that one there, so if I have the sine of 7.1 radians, it's 729 is my ratio of my opposite and hypotenuse. Okay? So the y values never get below -1, and they never get above +1. Does that kind of make sense? So when I take sine of, let's say, alpha here, or A, and I ask this thing to go from, because I'm in radians, I go -2 pi to 2 pi. So negative 360 to positive 360. Or I can go from negative infinity to positive infinity. As I move that thing through, no matter where I stop, the number is always going to be between -1 and +1. Does that make sense? This number right here, it's always going to be 0 point something. Okay? So what that means to me then, if I square a fraction between 0 and 1, take something like 1/7, okay? And you square 1/7, you get 1/49, right? Something smaller, correct? Okay? If I start with 1/2, I square, I get 1/4, something smaller. So when I take 1 minus a number between -1 and +1, but I square that number, so it's actually going to be 1, if it's a negative, well, if I just look at that, cosine squared, that result is always going to be positive, right? Okay? But when I go 1 minus in a positive number, but this cosine squared is going to be a number that is always smaller than 1. Does that make sense? Because I'm squaring a fraction that is between 0 and 1, so it's 1 minus something even smaller than that fraction. So, what I'm trying to get at here is that radicand is always going to be a positive number here. Does that make sense? Okay? So, you have plus or minus the square root of a positive number. Well, if sine is positive in the first quadrant, then we're looking, this is going to be a positive, and we're looking at the square root now of a positive number. In order to get the total to be positive, which one of these do I need to choose? Do I need the plus sign or the minus sign? Plus. So if they told you theta was in quadrant 1, you would say your answer would be sine of theta is equal to positive 1 minus cosine squared theta. Okay? And the idea there is, if we're going back to this, let's put it in degrees, just clear all this. If sine of theta and 1 square root of 1 minus cosine squared theta, if this number is between first quadrant, 0 degrees, 90 degrees, are these two numbers always, I'm in radians, there we go. Are these two numbers always the same when I do that? That makes sense? Sine's the same, right? Both positive? Okay. When we're in the second quadrant, let's say theta's in the second quadrant. Okay, so now that's theta. Okay. Sine is positive in the second quadrant, correct? Okay, sine is the only one that's positive in the second quadrant, so this is going to be a positive number right here. So again, the same logic, I need to pick off the positive square root. So if we go back to Desmos and we change this from 90 to 180, and I play that through, are these two numbers always the same sign, SIGN? Yeah, no matter where I stop it, they're going to be both positive. Okay? Now, when theta is in the third quadrant, so let me, just for the sake of cleaning the picture up a little bit, draw another one. If theta is down there, okay, the sign in the third quadrant, remember, all students take calculus, so tangent's the only one that's positive, right? So sine, if I write sine of theta, but theta's in the third quadrant, this number is actually going to be what kind of number? Negative. Okay? So when I have to choose to make the right-hand side the same, don't I need to take the negative side, or negative version of the right-hand side?
Yeah.
That makes sense, everybody? So here's the thing. If I go back to Desmos, let's make this go from 180 to 270, and I play that. Now look at how they are. This one's negative, right? That's what we said. The sign was going to be negative. Right now, this is positive, right? They're the same quantity, just opposite signs, right?
Yeah.
So that's why I've got to insert then the negative there to make them equal, right? And then the fourth quadrant will be identical. Fourth quadrant, because theta is residing there, cosine is the only one that's positive, so sine again, this number would be negative. So then you've got to choose the negative there. Yes?
So do all the answers involve square rooting?
A lot of them do, not all of them. Okay? So you're saying like every one of these questions that you see, like the one in your homework right here, does it involve a square root?
Yeah.
Not necessarily.
Okay, and then the quadrant is the size of
Yes. So the next one is express tangent in terms of sine theta. Now this is, I told you, not as explicit in regards to choosing which one of these options. Okay. Remember, tangent needs to be solved for, needs to be all by itself, needs to be isolated. Okay. And then on the right-hand side, the only thing we can see is the trig ratio of sine. Okay? So, maybe we go through these. Okay, and we look at sine theta equals sine over cosine. Okay. That uses tangent and sine, right? There's not going to be a way for me to get rid of that cosine. It's going to be kind of running that same issue that we had when we did this first one. Okay? You look at this one has sine in it, but it doesn't have tangent in it, right?
Yeah.
This one has tangent in it, but what is that, really? Yeah, it's 1 over cosine, right? So if they said express tangent in terms of cosine, that'd be the one you choose, because it's not explicit, it's hidden, but that's got cosine in it, okay? But it wants tangent in terms of sine. Looking at this one. Okay, explicitly tangent's not showing up, right? But is that 1 over tangent? Yeah, so tangent does show up on the left-hand side. And is that 1 over sine squared? Okay, so what we're really doing here is we're using that one in combination of that one there and that one there. So we're really using those three together to kind of get this completed, all right? And that I think is the tricky part of some of these. Okay, is really just trying to see where we start, and then to see substitutions. And that's the idea that I said about you're going to get better at these the more you see, because you're going to be able to you see kind of a similar substitution 2, 3, 4 problems in a row, then that kind of stays with you when you see your next handful of problems. Okay, you'll understand that's an option for you. So I'm going to start with 1 plus cotangent squared theta equals cosecant squared theta. Okay. There's a couple different things you can do. Okay. I'm a fan of trying to get the terms that I want my answer in to show up as soon as possible, so I can try to isolate them, okay? Because you could do some algebra here before you replace cotangent with 1 over tangent. You can do some work before you do the cosecant, or replace cosecant as 1 over sine. But I'm going to make that substitution right away. I'm going to replace this with 1 over tangent squared theta equals 1 over sine squared theta. There's a couple different things that we can do. We can, last class I think we went a little bit beyond what was necessary in order to isolate the tangent, okay? But it's ultimately up to you on what makes sense to you, okay? So what do you guys want? If I'm trying to isolate tangent, what do you guys want to do? You want to subtract 1 from both sides? Okay. So I got 1 over tangent squared is equal to 1 over sine squared minus 1, right? Okay. Now what do you think we could do? The issue here is if I square root the left-hand side, obviously I would get like 1 over tangent, right? Okay. And I can square root the right-hand side, but when we do, then that's fine. When we do that, like we don't want an answer, when it says express tangent theta, like that is exactly what you need on the left-hand side. You can't have like 1 over tangent on the left-hand side. Does that make sense? So if you do square root, I am not saying that would be incorrect. And maybe we can do that here in a moment. We would have to then somehow get that tangent to the numerator, right? Okay. Let me ask you this question. Is this a fraction? Are these 2 fractions? Okay. Let's do this. Let's go. And this is what I talked about yesterday and the day before, that this class is going to kind of broaden or refine your algebra skills. Can I rewrite the right-hand side as 1 over sine squared theta minus sine squared theta over sine squared theta? What did I do there? I changed my 1 into a convenient form of 1, right? Okay, but the algebra just said, essentially come up with a common denominator of the stuff on the right, correct? Does that make sense? Remember, I got 2 fractions over there, right? You remember what sine squared is. Sine squared of theta, when you know what theta is, that's a fraction, okay? So when I add 2 fractions, I need a common denominator. So now, if I look at it this way, I have 1 over tangent squared theta is equal to 1 minus sine squared theta over sine squared theta. You guys agree with that? Okay. Any ideas of what we can do next? You could, but that's going to get rid of your tangent then. And remember, we want tangent to be left over in our answer. You guys remember something like this? If I have like 2/3, give me a fraction that 2/3 is equal to.
4/6.
Okay. Now we know if that's a proportion because it's 1 ratio equal to 1 ratio, right? Do we have a proportion right here? Okay, so you could, so to tell that this is true, I can cross multiply. 12 equals 12, right? Here's kind of where I'm trying to go with this. When I rewrite 2/3 as 3/2, what did I do? Reciprocal. What's the reciprocal of 4/6? 6/4. Is this still true?
Yeah.
Because I'm all cross multiply, so we get 12 and 12, right? Okay. We got a ratio here equal to a ratio. We got a proportion. If I want to get tangent by itself, can I take the reciprocal of the left-hand side, and that'd be equal to the reciprocal of the right-hand side? Okay. So that is, well, that's what I was saying earlier, is that is a situation where we bring back some algebra that maybe we haven't seen in a while that becomes kind of part of our toolbox to work through these problems. And then you do that enough, that's going to refine that skill. And you're going to remind yourself, you're going to know, I've always got that ability, okay? Is that the only route? I don't think so. We'll talk about it again here in a moment, a different route. But now how do I solve for tangent? Square root both sides, so I go tangent of theta is equal to plus or minus sine squared theta over 1 minus sine squared theta, right? Yep. Okay. I'm just going to go one step further. When we have the square root of a fraction, because of our laws of exponents, we can change that to this, can't we? Plus or minus sine squared theta up top over plus or minus 1 minus sine squared theta on the bottom. Okay. But what's the square root of sine squared? Sine. Okay. Now, because we got plus or minus up top and plus or minus on the bottom, I really only need one of those. So I'll leave the one on the bottom. And then, so now I'm going to have tangent of theta is equal to sine of theta on top plus or minus the square root of 1 minus sine squared on the bottom. Okay? I'm going to stop right there. All right? You're going to come across, if you were to take this maybe at like Rhodes, where you got maybe a different professor, okay? They might give you rules at the beginning and say, we want to abide by all our algebra rules that the math community has abided by forever, and one of those rules is that you can't leave radicals in denominators, right? So they might ask you cannot leave your answer that way, you have to rationalize it, okay? There's a degree of simplification that we should always be kind of interested in. And the idea, usually they're going to say simplify it as much as possible, okay? And I'm going to work with you. I'll be lenient with you early on that, okay? I had a teacher in high school and I had professors in college that you had to simplify everything 100% as much as you possibly could, okay? Which is difficult, but at the same time, I think it's beneficial because you start to learn and refine those algebra skills. But at the same time, it's hard. So I'll get you there. I'll kind of help pull you along. Okay. Now here's my question. When we were at this step here in black, okay, this step where we took the reciprocals. Could we have done something like this? Because I heard, I think it was Blaze said cross multiply. So let's go sine squared. So sine squared now is going to give me tangent squared theta minus sine squared theta times tangent squared theta, right? You guys agree with that? Do both things over here on the right-hand side have a tangent in them? So can I rewrite this as tangent squared theta 1 minus sine squared theta? Which, I don't know why maybe I wrote that one, but that's just that times that, right? Drawn out or written out implicitly before I did the multiplication, right? Can I isolate tangent squared by dividing by 1 minus sine squared? And does that then leave me with just the tangent squared? On the left-hand side in this case, sine squared over 1 minus sine squared? Is that the same thing as that right there? Yeah. A different route to do it. Now I'm going to just kind of demonstrate with just pulling up what the last class did. We did it different. No, I think what we did last class is All right, so what we did is we went ahead, instead of, because you guys dictated this early on, you said subtract that 1 from both sides, right? Well, in last class we said, let's just take the left-hand side and combine that into one fraction. Does that make sense? Now, we ended up combining the right-hand side eventually into one fraction, right? So we still had to have that algebra at some step, but it was at a different step with different components, but it still was necessary. So when I make this tangent squared over tangent squared, get that phrase right there, now I've got that common denominator. Now I add the numerators, okay, and I get tangent squared theta plus 1 over tangent squared is equal to 1 over sine squared, right? We good with that? Then we cross multiplied there, okay? So cross multiplying gave me tangent squared times 1, so tangent squared. And then cross multiplying here gave me sine squared, tangent squared theta plus 1. Now, that looks a little bit like that last one we just did, okay, when we cross multiplied. But the one we did, I don't think it had the ability to, I think it, I don't want to phrase it, it had tangent out front, I believe, right? Okay, and we were able to isolate that pretty quickly. Here, the sine squared is out front. So now at this stage, I cannot isolate the sine the way it is. So what I have to do is I have to distribute. I get sine squared, tangent squared, plus sine squared. Now, I've got a tangent squared on the right-hand side, I got a tangent squared on the left-hand side. Let's move all that stuff over to the left. Okay, now you see that you've got common terms over here, right? Okay, there's a factor of tangent squared in here and tangent squared in there. Now I can pull that tangent squared out. And it would be 1 minus sine squared. Can you now isolate that by division? So divide both sides by that. And it gives you this, right? And that's exactly what we ended up with, correct? And then finish that off. But the argument is, if I give you guys this equation, if I give you say like 2x plus 4y equals 6x minus, let's not put a y on here, minus 12. And I ask you to solve for x. What are some options? Subtract 2x from both sides, right? Okay. But is there an alternative option of subtracting 6x from both sides? So that would be two different approaches, right? Could I have added 12 to both sides? There's a third approach. Could I have subtracted 4 from both sides? Yes. So the steps that you do, okay, if I gave that equation, not every one of us is going to subtract 2x first, and then add 12 second, and then divide everything by 4, right? Okay. Some people are going to do different steps, therefore it's going to lend them to different algebraic phrases. But as long as you abide by your algebra, you should be okay. All right. Now, as we go through this stuff, and you're questioning whether you've done something correct or not, let's go back to the ones we were doing. Okay. Let's say that I work my problem here, and I'm uncertain of whether this here is allowed to be done, that reciprocal process is allowed to be done. So what I would do is take my calculator and I would say, okay, when I have 1 divided by tangent squared of some theta, let's see what that gives me. And then I have 1 minus sine squared of some theta divided by sine squared of theta. And I would suggest you don't use a TI-83 for this because you're going to probably miss parentheses sometimes and mess things up, okay? If I use Desmos, that writes it just like I have it here, right? Okay, so that's going to be the benefit. So now if I choose like theta, let's say theta is like, just say 30. Because I get the same results here, does it tell me that these two things are equal? Okay. So then the next step was, well, I took that one and I found its reciprocal. So then that reciprocal would have been tangent squared of 30. And I'm questioning whether this was okay. Well, if I take the reciprocal of the left-hand side, is that okay when I take the reciprocal of the right-hand side? So now I'm going to write the right-hand side as sine squared of 30 divided by then 1 minus sine squared of 30. And I still get equivalent values, right? So it's showing me that, yes, you're fine. You have maintained an equation throughout this process, okay? If something was not allowed to be done, those 3s or 1/3 would diverge. It'd be different, okay? And that would tell you your algebra step that you did was not allowed to be conducted. And it doesn't matter what you choose for alpha, or I guess theta, I guess. It doesn't matter what you choose for theta, as long as it's consistent. I mean, don't choose theta to be 30 on the left-hand side and then be 45 on the right-hand side. That ain't going to work, okay? You got to have a controlled variable when we're doing that, okay? So one of the questions, so Blaze, give me that question that you had. So just give you a start on this. Actually, let's do this. I had somebody wanted to go secant of theta in terms of what is it? Sine. Or you do it the same way if it's secant or sine. We go through our ratios, okay, our trig identities. And I'm looking for ones that relate secant and sine, and there are none, okay? But there is one here like this, okay? Does that relate secant and tangent? So that's close. And the reason that's close is because the tangent have a sine in it. Can I write something like that? Does that make sense? So if I square root both sides, I solve for secant, right? And I've isolated secant. But it would be in terms of sine and cosine, right? Yeah. But that cosine can be rewritten because it's cosine squared, isn't it? And don't we have a third identity that says that? Cosine squared plus sine squared equals 1? Can I move that to the other side? Say cosine squared theta is equal to 1 minus sine squared. Does that make sense? Now can I come down here and replace that with 1 minus sine squared? Does that make sense to everybody? Okay. Now you square root, but what I would do, and this is something about with the idea of how far we need to simplify. If you are left with multiple fractions over here, you're probably going to want to find LCDs and combine them, and we'll draw you over here. If I write that 1 as 1 minus sine squared over 1 minus sine squared, I can now add these numerators, right? Don't I have 1 minus sine squared plus sine squared? What happens with those sine squareds? Cancel. I'm left with 1 here over 1 minus sine squared. I know, like maybe some of you are sitting here thinking, "This is awesome. I understand this. This is easy." I know some of you are thinking, "What in the heck just happened for the last 45 minutes?" Okay, I'm going to work with you. We're going to see lots of these over the coming weeks. It might seem initially that we kind of fade away from this within the next couple of days, but in Chapter 6, we'll talk about it again. Chapter 7 is fully devoted. That's all we do in Chapter 7. Okay? But I'll work with you. But we need to kind of develop those skills. Yes?
What does that first equation come from? That 1 plus tangent squared theta equals secant squared?
So that was one of these.
You should just email that picture to us. I don't have to do it.
I did email this to you.
You did?
Yeah, you have this. I emailed this to you like before Christmas break.
Can you email it again? I don't remember that. And what's your middle name?
Thomas.
Oh. Hey.
So it's one of these.
Do you live by Springbrook? No, do you live in Montague Drive?
Why do you know where I live?
It was him. You got a speeding ticket? Yeah, you got a speeding ticket?
Oh, yeah, that was a long time ago.
Yeah, I saw it. It said 10 days in jail. 10 days.
No,